So in this video we're going to continue our learning of electrostatics by discussing the concept of polarization and end with an introduction to the variety of traditional science equipment that can be used to induce and store charge, some of which can be easily made at home and many of which we will work with in activities in class. So here we go. So polarization explains how a neutral object can be attracted to a charged object. You can easily experience polarization by rubbing a blown-up balloon against some fabric and sticking it to a wall. When you did the tape experiment in the previous video, if the tape stuck to your hand as you pulled it out of the roll, that's because of polarization. The polarization of charge will be very important in Part B of Unit 5. When you bring a charged object near an uncharged object, the uncharged object gets polarized. Let's use sticking a balloon to a wall with static electricity as an example. Now, if you've never done this, I want you to pause the video right now, go find a balloon, blow it up, rub the thing on your shirt or a wool sock or something, and stick the charged up part of the balloon on the wall. Once you've done that, not only will your childhood be complete, but you'll know what we're talking about. Now, think of the molecules that make up the uncharged object. In this case, that would be the molecules of the wall. The wall molecules themselves have no charge, but when the charged up balloon comes near the neutral wall, the electrons in the wall molecules are either attracted to or repelled from the balloon. This motion happens because of the nature of the covalent bond, the sharing of electrons thing. So the electrons try to get away from a negatively charged object, or they get attracted to a positively charged object. One of the things that we'll find is that all plastic things tend to get charged up negatively. So a charged up balloon has a bunch of negative charge on it. So that will cause the charges in the wall to get repelled away from that charged up balloon. The net effect of this is to cause the molecules to have a positive side and a negative side. Even though overall they're electrically neutral, as long as a charged object is nearby, the molecules will stay polarized. The force generated in polarization is called a polarization force, and that polarization force arises due to the separation of charges in the wall molecules, not because the balloon and the wall are oppositely charged, but because the charges in the wall get pushed away from the charges in the balloon. You can also experience polarization by taking that charged up balloon and setting it next to a slowly moving stream of water. So just turn on a sink so that a small stream of water comes out of it, and then put a charged up balloon next to it. It's going to deflect those water molecules, showing that the water molecules are polar and can align themselves to be attracted to charged objects. So one of the things you will have been able to observe is that when a charge goes from one object to another, it can travel through the air in the form of a spark. Sparks can be barely noticeable, or they can be so massive that it's impossible to ignore them, like a lightning bolt. So the bigger the charge difference between two objects, the more the charge wants to move. If the charge is big enough, it's going to ionize the air molecules between the objects. The charge can then travel through the ionized air, and this is what we call a spark. So there's several pieces of equipment that have been in use for centuries for discovering things about charge. We're going to discuss these because you're likely to find references to some of them in problem situations, and you need to have an idea of what they are and what they do in order to be successful in those situations. So we're going to talk about the electrophorus, electroscopes, and Leyden jars. So first, let's talk about the electrophorus. The electrophorus is a great piece of equipment. It was invented by Alessandro Volta in 1775, and it seemed to be like an almost endless source of charge. The electrophorus has two parts. It has a base made from an insulator and a metal plate that has an insulated handle. Here's how we use it. The first step to charge is to charge up that insulator base by rubbing it with a cloth or fur, and then you hold on to that insulated handle of the top piece and place it against that insulated base. So what you've done by rubbing that insulated base is charged it up. You either charge it up positively or negatively depending on the material that it's made with. For example, if we could make an electrophorus very easily with a pie plate and a styrofoam cup, and then rub a piece of plastic with a cloth, and we charge up that piece of plastic. Put the pie plate on there by holding on to the styrofoam cup that's attached to the pie plate, and we'd be able to get the charge off of that piece of plastic. Now, once you've touched the electrophorus to that insulator, you touch the top conducting piece of metal with your finger, allowing those electrons a place to go. Okay, they move off through you to the ground, giving that plate a positive charge. Then you pick up the plate and it's got a positive charge on it. Now, depending on the type of material that insulated base is made out of, you're going to end up with a positive charge or a negative charge on your electrophorus. The charge that results on that conducting plate is always going to be opposite that charge that's on the insulating plate, which is a characteristic of charging by induction. Okay, so then let's talk about the electroscopes. Electroscopes are useful devices to measure charge. There's several different styles that are available. Each of them will indicate whether an object is charged, and they can be simply constructed or they can be really fancy. The fancy ones have like a needle and a projector that can project an image on a screen. We're going to play around with the simple ones in class. There are the simple types are these foil on thread types and a twin hanging leaf type. So the foil on a thread type are made from a light piece of metal foil that's attached to an insulated thread. We can make these with a ring stand, a piece of string, and what's called a pith ball wrapped in tin foil. So the way they work is a charged object will be brought near the foil. The foil will be polarized and attracted to that charged object. So when it touches that charged object, it gets charged up by conduction. And now it has the same charge after it touches that charged object, and so it will be repelled away. The angle that is formed by the thread with the vertical is proportional to the charge. So if the foil is charged by like a rubber rod, then you know it has a negative charge because rubber will always charge up negative. An unknown charge can be brought near the foil. If that charged foil is attracted, then you know that the object has a positive charge. So remember, unlike charges attract, if the foil is repelled, you know that the object has a negative charge, like charges repel. So then there's the twin hanging leaf type of electroscope, and these type of electroscopes are usually enclosed in a transparent box or beaker, and we have a metal rod that is mounted on its top. Let's call the metal rod an electrode. The rod goes through the box where it has two very thin metal foil leaves attached to it. The metal leaves hang down and are separated by a small space. They're both attached to that rod. So let's imagine that we bring a positively charged rod near the electrode of this twin foil leaf electroscope. When we do that, we cause the free electrons in the foil to travel up that rod into that electrode and onto the positively charged stick. If we've touched, then we're charged by conduction. That leaves a positive charge in the foil, and those foil pieces will be repelled away from each other. The angle that they make is proportional then to the size of the charge that was in that original rod. So we can use these electroscopes to measure the size of the charge on some other object. Let's say, for example, we charge up an electrophorus. Say we give it a positive charge. We can bring it to an electroscope to transfer the charge and thereby measure the strength of that charge. So the question is, how does a positive charge transfer? Well, as the electrophorus nears the ball on the electrode, of the electroscope becomes polarized. Free electrons collect on the ball, attracted to the positive charge on the plate of the electrophorus. The electrophorus has a pretty good charge, so usually the electrons will be so attracted to the plate as it nears that they will ionize the air and jump to the electrophorus in the form of a spark. The electrophorus is slightly less positive, having collected some electrons, and the electroscope is positive, having lost free electrons. The degree to which the electroscope is deflected then gives us a measure of the size of the charge on that electrophorus. So then now let's talk about Leyden jars. So the Leyden jar is a type of capacitor or device that stores charge. Back in 1745, a guy named Ewald George von Kleist developed this device. So it was the first method discovered to store a significant amount of charge for later use. The Leyden jar was it was an accidental discovery, really. Kleist apparently thought that electricity was a liquid. It made sense that it might dissolve in water, so an attempt was made to put some charge in a beaker of water. He hooked a wire in the beaker to an electrostatic generating machine. Holding the beaker in his hand, he cranked up the machine to generate charge. So it turned out that the electricity did go into the beaker, but it didn't dissolve in the water. It was discovered a bit later when he had an assistant who touched the wire in the beaker while holding the outside of the thing and got a tremendous shock. That shock was so painful and shocking that Kleist gave up on the whole thing. But we get out of it a Leyden jar. So a Leyden jar is simply a jar that has a conductor on the inside lining of its inner surface and a conductor on the outside surface. An electrode sticks up above the jar through the lid. The electrode is connected to the inner conductor. So, like a classic Leyden jar has a metal foil lining the inside lower half and a similar coating on the outside. The electrode in the center makes electrical contact with the inside metal layer through a chain. You can easily make a Leyden jar by taking a plastic container, wrapping the inside and outside with foil, and putting some sort of metal rod like a screw or a long nail in there so that it touches the inside piece of foil. The key part of a Leyden jar is that you have to have two conductors separated by an insulator. Another common way to make a Leyden jar is to have like an electrolyte solution on the inside, something like salt water, and a foil lining on the outside. The electrode pokes down into that electrolyte. So remember, electrolytes are solutions that conduct electricity. Salt water is an electrolyte, so that would make a Leyden jar. So when a charged object like an electrophorus is brought near the center electrode, the inner conductor becomes polarized. In this drawing, a positive charge is brought near the electrode. The free electrons flow to the top of the ball, attracted by that positive charge. The inner conductor has a positive charge because the free electrons have left. They've made their departure. The outer conductor is also polarized. Just across the insulator is a strong positive charge, so those free electrons are attracted to the surface of the conductor, of the insulator. To charge the Leyden jar, the outside conductor has to be grounded as the charged object is brought to that electrode ball. Usually, the charge will jump to the electrode in a spark. If the outside of the jar isn't grounded, you can't store charge in the jar. The grounding is usually done by holding the jar in your hand or something. So with a ground attached to the outer conductor, electrons flow from the ground into the outer conductor. The free electrons in the top of the electrode flow into the positively charged object, and you end up with a negative charge on the outer conductor and a positive charge on the inner conductor. They stay in place because they attract each other across the insulator. You can pick it up by the outer conductor and the charge stays in place. That's how the Leyden jar stores charge. Okay, so those are 4 pieces of equipment. We're going to be looking at some of them in class and doing some activities involving them. See you then.